Joyful day, everyone! Welcome to the first episode of AI Sparks, where I will be covering quick deep dives into various emerging tools and technologies. This AI Spark is about OpenEvolve, an open source implementation of AlphaEvolve from Google. As we covered in one of the episodes of AI Blitz podcast, within 48 hours after Google published the AlphaEvolve, several open source implementations emerged. Today we will focus on OpenEvolve implementation from Codebase. See the links in description. The AlphaEvolve as well as OpenEvolve aim to provide a framework where you can evolve your code. The underlying idea is simple. You have a function or portion of code in your codebase that you think could perform better. You mark the code segment that you want to evolve and write an evaluation function that will basically serve as the guide for the framework to determine whether the new version is better or worse as previous one. With these two steps and a simple configuration, you can run the evolution that will use LLM to generate new possible solution and score it. Once the evolution finishes, you will have a code implementation that scored best through all the iterations. Of course, the actual implementation is much more sophisticated, but you got the idea. Let's look at the actual usage. I have a sample application code here that solves the settlement problem. You know the struggle when you go with your friends on a trip, you pay a dinner for all, someone else pays an Uber. After the trip, you want to settle the expenses. The naive implementation here calculates the fair share, basically splits the total expense evenly across the group. Then we calculate the balance for everyone based on what he or she actually paid. We select a central person that will collect all payments and distribute to settle. Then everyone with debt sends the owed money to the central person. And the central person distributes to everyone that paid more than fair share to settle. This approach works, but as you can imagine, using the central person introduces unnecessary transactions, and the whole settlement can be done more efficiently. Moreover, it adds too much stress for this poor central guy. Next, we need to mark the portion of code that we want to evolve by the comment marker in the beginning of the block. And at the end, we have the evaluation function that takes program path as an argument, loads it, and looks for the settle expenses function. Then it iterates through several test cases and calculates an overall score based on the results. The actual algorithm here is not important for our evaluation, but the higher the number of transactions in suggested settlement, the lower is the score. We want to have as least transactions as possible in the settlement. Of course, the final settlement needs to distribute the expenses uniformly for it to be considered. The evaluate script here just runs the evaluation for current implementation, not needed for the evolution itself. And last piece of the puzzle is the configuration. Here we need to provide information about which LLMs we want to use, as well as other parameters, modifying how the evolution will be performed. What I am providing in this example, apart from the number of iterations, is primary and secondary model that are used. Necessary information for the API access. For example, the endpoint of the OpenAI API and the API key, so that the OpenEvolve can access it and a prompt to use. With this simple setup, we clone the OpenEvolve repository. And we execute the evolution. We provide the file with the code block we want to evolve, the evaluator, and the configuration. The evolution starts using the LLM to generate new candidates and scoring the candidate with the evaluator we provided. We can see the score of the initial implementation. We can also see the default configuration of the ensemble, using the primary model 80% of time and the secondary model 20%. These weights can be changed as part of the configuration. We can see that the iteration 1 improved the score of the original algorithm to 0.625 and continues to iterate. After the 10 iteration that we set in the configuration, we get the score the best candidate. The actual implementation can be found in OpenEvolve output folder in the subfolder best. When we look at the algorithm, it calculates the fair share. Then it calculates the balances for each person, taking into account how much they paid. The algorithm then splits the group into debtors and creditors based on the balance, sorts them, and iterates through the both lists, going from the individuals with highest debt or credit and generating settling transactions. This approach is definitely much more efficient as it distributes the transactions instead of using a central person to distribute. The OpenEvolve framework provides much more options than we leveraged in this example. You can set additional parameters for the models, modify the prompt configuration, adjust the parameters of the evolution algorithm and evaluation. Some of the configuration parameters can be provided directly from the command line, like the number of iterations. OpenEvolve uses map elites under the hood. That is great especially for problems like code evolution, because it is capable of maintaining the diversity of solutions with different trade-offs. The characteristics used are the complexity of code and the fitness score. You can find more information in the description. I hope you found this AI Spark useful. Let me know if you would like me to cover some other topic, and please subscribe to support me. It is free for you and it helps me a lot. And let me know if you found all the 3 secret messages in video. See you next time.